They were going to go to the moon, pick up a bit of dirt, take it back, and say, look at how clever we Soviets are.
The Soviet Union was 3 weeks away from building a permanent military base on the moon. Declassified documents from 2019 reveal that in 1975, the USSR had construction crews trained, transport rockets ready, and a site selected on the lunar surface. Then the entire program vanished overnight, erased from Soviet records until Russian space historians published the classified blueprints 4 years ago.
N1 was a super rocket, counterpart to American Saturn, to launch Soviet counterpart to Apollo to the moon.
This wasn't a concept. This was a funded, approved military installation designed to house 12 cosmonauts permanently, equipped with nuclear reactors for power and surface-to-space weapons capable of targeting American satellites. The base had a name, Zvezda, which means star in Russian, and construction materials were already manufactured and sitting in warehouses outside Moscow when the program got canceled. The question isn't why the Soviets planned a moon base. The question is why they stopped when they were this close to building it. The declassified documents show that Soviet planning for a permanent lunar base began in 1962, the same year Kennedy committed America to landing on the moon. While NASA focused on winning the race to put boots on lunar soil first, Soviet engineers at the Energia Design Bureau were designing something more ambitious, a permanent presence that would outlast any American landing mission. Chief designer Vladimir Chelomey presented the Zvezda-based design to the Soviet military in 1964. The proposal called for a modular habitat built from cylindrical sections, each launched separately, and assembled on the moon's surface by cosmonauts wearing reinforced pressure suits. The base would be buried under 3 meters of lunar regolith to protect crews from radiation and micrometeorite impacts. The base design included 6 habitat modules arranged in a hexagonal pattern around a central command module. Each habitat could support 2 cosmonauts for 6-month rotations. The entire complex would house 12 people permanently, with resupply missions arriving every 3 months carrying food, water, and equipment. Power would come from a nuclear reactor, specifically the Romashka reactor that Soviet engineers had already tested in Siberia. This wasn't theoretical technology. The Romashka had operated successfully for 15,000 hours in ground tests, generating 500 kilowatts of electricity using thermoelectric conversion. The lunar version would be buried in a crater near the base to contain radiation, while cables ran underground to the habitat modules. The declassified blueprints show details that prove how close this came to reality. The habitat modules weren't conceptual drawings. They were engineering schematics with precise measurements, material specifications, and assembly instructions. Each module measured 6.5 meters in diameter and 12 meters long, constructed from aluminum alloy with a double wall design. The inner wall provided pressure containment, the outer wall served as a micrometeorite shield, and the gap between walls contained water for additional radiation protection. Life support systems were designed around closed-loop recycling that Soviet engineers had developed for their Salyut space stations. The base would recycle 95% of its water through filtration and distillation, with only 5% requiring resupply from Earth. Oxygen would come from electrolysis units splitting water into hydrogen and oxygen, with carbon dioxide scrubbers using lithium hydroxide canisters that could be regenerated rather than replaced. The Soviet plan included something NASA's Apollo program never attempted: local resource utilization. Zvezda base would extract oxygen directly from lunar soil using a process called hydrogen reduction. Lunar regolith contains oxides, compounds with oxygen bonded to silicon, iron, and other elements. By heating regolith to 900 degrees Celsius in the presence of hydrogen gas, those oxides break apart, releasing oxygen while creating water as a byproduct. Soviet engineers calculated that a crew of 12 would consume approximately 10 kilograms of oxygen per day. A single hydrogen reduction processor could extract that much oxygen from 300 kilograms of lunar soil, which a robotic excavator could collect in less than 2 hours. The transportation system was equally detailed. The base would launch from Baikonur Cosmodrome using the N1 rocket, the massive launch vehicle the Soviets developed to compete with NASA's Saturn V. Each N1 could carry 95 tons to low Earth orbit, enough to launch 1 complete habitat module plus the crew capsule that would transport cosmonauts to the moon. The mission profile called for 14 N-1 launches over 18 months. The first 6 launches would deliver habitat modules, the nuclear reactor, life support equipment, and construction machinery. Launches 7 through 10 would deliver supplies, scientific equipment, and defensive weapons. The final 4 launches would transport the 12-person crew in groups of 3. Cosmonauts would land using the LK lander, a smaller version of NASA's lunar module designed to carry a single cosmonaut. But for Zvezda construction, Soviet engineers modified the LK to carry 3 cosmonauts plus 500 kilograms of equipment. The declassified documents show test landings of this modified LK at a secret facility in Kazakhstan, where cosmonauts practiced assembling habitat modules in simulated lunar gravity. The base location had already been selected, a site near Manzinus crater at the Moon's south pole. Soviet lunar probes had mapped this region and identified areas that receive near-constant sunlight, critical for solar panel backup power. The South Pole also contains permanently shadowed craters that Soviet scientists suspected held water ice, confirmed decades later by NASA's Lunar Reconnaissance Orbiter. Here's where the program gets darker. The declassified documents reveal that Zvezda wasn't purely a scientific outpost. It was a military installation with offensive capabilities. The base design included a separate weapons module equipped with what Soviet documents call orbital defense systems, which intelligence analysts now believe were anti-satellite weapons designed to destroy American reconnaissance satellites. The weapons system used a design called Noodleman-Richter NR-23, a modified aircraft cannon adapted for vacuum operation. In the airless environment of the Moon, this cannon could fire projectiles at satellites in low Earth orbit, approximately 300 kilometers above Earth's surface. With no air resistance, projectiles would maintain their velocity indefinitely, making even small impacts catastrophic for satellite electronics. Soviet military planners calculated that a Moon-based weapons platform could engage American satellites as they passed overhead, providing the USSR with the ability to blind American reconnaissance capabilities during a conflict. The permanent nature of the base meant these weapons could operate indefinitely, unlike satellites which have limited operational lifespans. This military dimension explains why the CIA tracked the Zvezda program obsessively. Declassified American intelligence reports from 1973 show that U.S. analysts knew about Soviet moon base plans and considered them a serious strategic threat. One CIA assessment warned that a Soviet lunar base with anti-satellite weapons could fundamentally alter the strategic balance by denying the United States access to space-based intelligence. The program reached its peak funding and urgency in 1974. That year, the Soviet Union allocated 2.8 billion rubles to the Zvezda program, approximately 15% of their entire space budget. Manufacturing facilities across the Soviet Union were producing components: habitat modules in Khrunichev, life support systems in Zvezda, nuclear reactors in Krasnaya Zvezda, and pressure suits in Zvezda Factory No. 918. Training for the first construction crew began at Star City, the cosmonaut training center outside Moscow. 12 cosmonauts were selected for what Soviet documents called Program Zvezda Group 1. These weren't test pilots like the early space race cosmonauts. These were engineers, geologists, and construction specialists trained to build and operate a permanent facility. The declassified training records show these cosmonauts practiced habitat assembly underwater in massive neutral buoyancy tanks, simulating the reduced gravity they'd experience on the Moon. They trained for 8 hours daily, 6 days per week, for 18 months. Each cosmonaut specialized in specific construction tasks, some focused on connecting habitat modules, others on installing the nuclear reactor, others on setting up life support systems. By early 1975, the program had progressed to final preparations. The first habitat module sat on the launch pad at Baikonur, mated to an N-1 rocket and ready for launch. The nuclear reactor had passed its final safety tests. The first crew had completed training and was waiting for mission assignment. Then, in March 1975, the entire program stopped. The declassified documents don't explain why Zvezda was canceled. That decision remains classified even today. But historians have pieced together what likely happened by analyzing Soviet economic and political conditions in 1975. First, the N-1 rocket had failed every single test launch. Between 1969 and 1972, the Soviets attempted 4 N-1 launches. All 4 exploded, either on the launch pad or within minutes of liftoff. Without a reliable heavy-lift rocket, the entire Zvezda program became impossible. Soviet engineers were working on fixes, but each explosion set the program back months and consumed massive amounts of funding. Second, the Soviet economy was deteriorating. The 1973 oil crisis had devastated Soviet export revenues, and domestic agricultural failures meant the government was spending billions on grain imports. Space program funding that seemed justified during the 1960s prosperity became increasingly difficult to defend as Soviet citizens faced food shortages. Third, the Apollo-Soyuz test project, a joint American-Soviet space mission scheduled for July 1975, created political pressure to de-escalate the space race. Soviet leadership saw détente with the United States as economically necessary, and a military moon base directly contradicted that diplomatic strategy. The declassified documents show that in April 1975, the Soviet Politburo held a secret meeting where they voted to cancel Zvezda and redirect its funding to the Salyut space station program and unmanned planetary probes. The vote was not unanimous. Several military officials argued for continuing the program, but economic reality won. What happened to the hardware? The declassified records reveal that habitat modules built for Zvezda were repurposed for the Mir space station program in the 1980s. Some of the technology designed for the lunar base, closed-loop life support, radiation shielding, power systems, eventually made it to space aboard Mir, just not to the moon. The nuclear reactor built for Zvezda never launched. It remained in storage until the Soviet Union collapsed in 1991, when it was decommissioned and buried in a nuclear waste facility in Siberia. The weapon systems were allegedly dismantled, though some intelligence analysts believe components were used in Soviet anti-satellite programs that continued through the 1980s. The 12 cosmonauts trained for Zvezda construction never left Earth. Most continued working in the Soviet space program, eventually flying to space stations or serving as mission controllers. A few retired from the space program entirely, their years of training for a moon-based mission that never happened. The blueprints, training records, and program documents were classified as top secret and stored in Russian Space Agency archives. They remained hidden for 44 years until 2019, when Russian space historians received permission to publish portions of the Zvezda documentation as part of a research project on Soviet lunar programs. Today, the declassified Zvezda documents offer a window into how close humanity came to having a permanent presence on the moon by the mid-1970s. Not from the country that won the race to land there first, but from the one that planned to stay. The base would have represented an extraordinary achievement in engineering, construction, and human endurance. It would also have militarized the moon in ways that might have escalated the Cold War into space, creating an arms race beyond Earth's atmosphere with unpredictable consequences. The Soviet moon base that almost happened wasn't canceled because it was impossible. It was canceled because the Soviet Union couldn't afford it, couldn't rely on their rockets not to explode, and couldn't justify the political cost during an era when cooperation with America seemed more valuable than competition. 3 weeks from construction, 12 cosmonauts trained and ready, modules built and waiting at the launch pad. Then nothing, just classified documents sitting in archives for 4 decades, preserving the record of humanity's closest attempt at claiming permanent territory on another world.